Here we go. Okay, where the hell is my screen sharing now? Here we go. Okay. For the recording, arrays collect a collection of items. They are stored together. We have zero indexing. So well, I want to store 1, 2, 3, 4, 5. But actually, what I normally do is I just add a zero that you don't need at the beginning. Now this is index 0, index 1, index 2, index 3. Everything is nice. We're all happy, and everything makes sense. But there are cases where you're going to need like zero indexing, so be careful about it. Yeah, and I guess you just have to get used to it. There really isn't too much of a workaround. Okay, how do you declare an array? Well, there's two different ways. First, you can do it this way, which you basically just say, okay, let's define an integer R1. This you've seen before. This is how you would define just a single integer. But if we want to define an array of a certain variable type, sorry, yeah, long story short, I'm at a summer program right now, and like, I'm not in my room because, yeah, so sorry for the disruption, everyone. Basically, yeah, if you want to declare an array, you just add a bracket and then the size of the array behind it. And basically this will say, okay, allocate 10 spaces in the memory for me to store some amount of integers. And then this is good. You've just declared an empty array of integers with 10 elements. And if you want to go check it out, you can go check it out. And then the other way to declare it is you can say first, okay, whoa, I don't really want to tell you how big it is yet because I can just give you a bracketed list of numbers. I can just basically just give you the array here. So maybe you remember when we were talking about strings, you can do like string s equals a, b, c, d, e. Well, this is kind of similar. You're basically just saying, okay, this is the string I want you to be, and then I'm going to say s, you be this. This is the same thing with R2. For R1, you're going to have to individually initialize each element within the array, but yeah, for R2, this is just it. Everything already has been initialized. So, okay, pop quiz. What is the index of this element? Elaine, you're banned from answering this question, but I have another correct answer. It is in fact 1. I have no idea why I just did that. Sorry. Yeah, but yeah, it's 1. Oh, what? Wait, is that a weird bug? Weird bug, okay. But yeah, yeah, I did not choose the best of places to be right now. So yeah, this is index 1, index 2, index 3, index 4, and obviously this is index 0. Right, next. Arrays have to be the same type. I've kind of alluded to this, like, if this is an int array you define, then all these guys have to be ints. In Java, you can do like you can have like an array of objects, and like an object can be anything, which will allow you to do it. In Python, anything is anything, so you don't really have to care. I think, yeah, Python is really weird. But yeah, I don't think Python cares. But yeah, here if you in C++, you have to have arrays be the same type. And this is just the error message that you will get if you try to be a bad person and initialize it of the wrong type. Okay, now let's have some practice. Please just send me the code that you would write for declaring your own double array. Meanwhile, I will try to get my Replit set up. Declare double array size 10. What would you code for that? All right, I have a bunch of correct answers. You don't have to do all the include using namespace STD stuff. That I assume you know how to do, and you'd probably just do it anyways if you want to. Okay. Now, what if you want to initialize it to 1.0, 2.0, 3.0, 4.0, and 5.0? How would you do that? James, not quite actually. There is another special, I guess, set of characters that we must use to declare a double to initialize an array. Nini, check how many equal signs you have. Although I think this could just be a typo. Alan, that is correct. James, that is right. Good job. I'll let a few more answers in. How about people who haven't answered? What's Alex or Alexander? Alex or Alexander, do you have any uh Alex or Alexander, do you have any ideas? Elaine, that is correct, I think. Although you should probably use a few more spaces. Alex or Alexander, are either of you here? W, I guess. Now try like the initialization. Initialize the values from 1 to 10. All right. Okay. All right. Seems like we've all had a bit of time, so here we go. Oops, wait, I am way too far ahead. Hold up. Here we go. This is the answer. I think a lot of you got it correct. I think, as Elaine pointed out, it's also possible to have both the size and the like array inside, but obviously you have to make sure that they're consistent. But yeah, that's it for declaring arrays. How should we access elements in an array? Well, to do that, we also use brackets, but now it's not like a variable declaration form. We just add it at the end of the variable name to create index. So, like for example, if you want to access the 1th element of the array, then we just do r brackets 1. Elaine, how did you predict what question I was going to ask? Anyways, Elaine's reading my mind or something. I don't know. But anyways, the question is, what is the value of a? Alan, correct. Good. Nini, good. Just give just a few more seconds. Elaine is a psychic. I'm beginning to think that. James, that is correct as well. Elaine, if you can guess. Oh, wait, is it on the screen? Oh, that's true. The question was on the screen. Never mind. Anyways, if you can guess which number between 1 to 10 I'm thinking of right now, I will be very impressed. Alex, that is correct. Yeah, so yeah, A is just gonna be 2. Doesn't look like anyone got tripped up by 0 indexing. Remember, this is going to be element 0, and then this is elements 1, 2, 3, and 4. So yeah, that's just how to access elements. Okay, yeah, A equals 2. Yeah, there. Okay. How do we change the elements in the array? Well, yeah, I guess this is also kind of an intuitive question to ask. With, I guess when we're considering any form of data, we always want to consider two things. Whether you can, how you're supposed to be able to retrieve the data, and whether you should be able to modify the data. Retrieval is kind of obvious. Like if you're going to store some data for some reason, you better be able to retrieve it, otherwise it's useless. Modification, normally you'd want to modify, be able to also be able to change what you're storing. Like it would be really bad if you if you had a variable for someone's salary and you can never change it, that would be kind of sad. But in some cases where you're like concerned about other people like maliciously changing the values, like for example, you don't want anybody to change like your bank accounts, your bank balance or anything. So that you can take precautions against. But yeah, anyways, how to change the element in array, we can basically just reassign the value that is we denote by the index. So yesterday I mentioned how like a function call can be treated as a variable, basically an array and an index with brackets inside. That will also be basically treated as any old variable. You can pass it into functions, you can do a bunch of cool stuff with it. Yeah. By the way, I think this notation means that you are like, it's very complicated. I think that's how you pass arrays into functions, but like, if I'm going to be completely honest, I'm not very good with passing arrays into functions. I need to look it up. Pause. Did Ethan explain global variables on the first day? Global versus local variables? Yes. Okay. Uh, yeah. So normally I just store all of my variables globally. Whether this is a good idea or not is questionable, but yeah, it just saves a lot of time. Yeah, you can access it. Okay, right. Give me a sec. Right. So yeah, that's how to change elements in an array. And for example, yeah, if we were going to print out what this is, originally we have 1, 2, 3, 4, 5, but once we modified the 0th element, now this becomes 5, and so we just get 5, 2, 3, 4, 5. Okay. Now, we may or may not have a bit of a problem. Does anyone have any idea what it could be? Looking at you, Elaine. It's redundant? What is redundant? Changing number, well, I guess I'm talking more about like the general structure of the array. I'll give everyone a few minutes to think about what could be wrong? Anyone have any ideas? Okay, maybe I shouldn't have asked this question anyways. Let's see. Where the heck did the screen go? Here we go. Oh, never mind, we have two. Okay, Elaine, you are correct. The size is fixed. I guess moving array elements kind of, I suppose. I suppose that's kind of getting to what I meant. But most importantly is the size is fixed. Let's say you want to store like some information about students in a class. What if a student like enters the class? What if a student drops out? Do you need to redefine the array? That's going to be really expensive. There might just be like 30 students in a normal class. But what if we're like talking about millions of elements? Then would you have to like redefine a million integers? Like, I guess a computer is fast enough that it can assign an array of million elements really quickly, but if you have to do this a lot of times, then that can start taking a toll. So it's a solution. It's the other half of the title of today's class, vectors. A vector basically is a dynamic array, meaning that you can change the size of it. How exactly it does this is actually quite fascinating. I don't think we'll get to it, but if you're really curious, you can search it up, like how vectors like reallocate memory. Because a vector is really just a glorified array that can, yeah, it can like it has to redefine itself, but it does so sparsely enough that you don't really feel it most of the time. So, okay, now we're going to redo this entire class, but with vectors. First, how to declare a vector. First of all, you are going to need this. You're going to need to include a vector. And I guess if you're doing bit/sdc++.h, then that's fine. But yeah, otherwise you're going to need to include vector. And you define it is a vector angle brackets, that's what it's called. Yeah, you're gonna need to do vector angle brackets typed inside. So this is very complicated. I think this is called a template or something. Basically, a vector is a variable type, and then you can specify the variable type that it's storing, yada, 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 a bunch of random stuff. Just know this is how you define it, right? You can define it raw like this. That means it'll have initially a size of 0, or you can do you can initialize it with a certain size. So yeah, I think you can also define it with two parameters. Um, like I think this should be the size and this should be the initial value inside. And then basically can help if it's all the same, then it can help you like initialize stuff. And if any of you are thinking, hey, this looks a lot like a function call, well, that ties in a bit of both elements of yesterday's class actually, between function and structs. This is called, I think it's what's called a constructor for a vector, but like it's complicated. Basically, it just specifies how you're supposed to make the vector. Anyways, yeah, that's how you create a vector. And I actually have I want to go back to arrays for a second because there's an interesting thought I want to do with you. Okay, for this array, can someone tell me what array of -1 would print and what array of 5 would print? Oops. Balance. Okay. Um, aha. I see a lot of Python thinkers in here. Mini is the closest. I see everyone is saying 5 and 1. Can someone explain the logic to that? Alan, why did you say 5 and 1? Let's actually try it out. Okay. Okay, Alan, you now have the correct answer. In Python, array of -1 will go to the back. That's really convenient. That is not something that C++ does, unfortunately. Yeah. In Java, it's gonna get really messy. Java will throw like some random exception or something, and it will be mad. Strangely, none of you said compilation error, which I feel like I would think is kind of logical. But okay, let's just run it. Let's see what it does.
You forgot to put the using namespace.
Yeah, I have a default template, so like I don't. Okay. Oh, actually, ooh, this one actually threw a compilation error. I'm actually surprised. Normally, it might not do that, actually. Can we trick it? And by the way, it's entirely legal to, like, just, yeah, have this in here. Yeah, okay. It just printed out 691453768. If anyone wants to tell me where this number comes from, I'll give you a million points because I don't know. Actually, I guess if I want to be really technical, it is the element that's stored right before the string, but it's not part of the array, so you really don't know what it is. This is just some random gibberish that means nothing bad. Out of curiosity, I'm just gonna see what 5 prints. Oh, look, it just completely threw up. This number isn't even consistent. Yeah. Uh, what's the term for that? I forgot what the term for this is. Okay, yes. The term for this, if you go out of bounds, this is what's known as undefined behavior. Basically, what this means is, okay, undefined behavior is just fancy language for we don't know what's going on. We have no idea what's going to go on anymore. Basically, as soon as you hit an undefined, sorry, as soon as you hit this, the rest of your code output can no longer be trusted. Like, what if I said this? It might give me 4, but now I've just modified some random ass value that I didn't know it was there. What if there was another important variable there? Somehow I've modified it. Did I actually modify it? What's stored there? It's a whole can of worms that usually we don't want to get into. So remember to keep track of your indices, everybody. All right, that was just a quick little PSA. I'm going to move on with the class now. Vectors. Okay, how to declare a vector? We just went over that. This is just 10 values of 20. This is how you declare and you initialize everything to a non-zero value. How do you change elements in a vector? Exactly the same as the array. Or not. Wait. Oh, no. Sorry, this is wrong. Yeah. You can just, it is exactly the same as the array. You can just do like a 4 equals 5 or something, assuming assuming 4 is a legal index. that you can change. But okay, we have a new operation to contend with. I have no idea what this code does actually. Okay, we have a new operation to contend with before I want to go into this. Inserting and deleting. So, as you probably recall from like 10 minutes ago, we said that arrays cannot change size. So we never had to contend with this for arrays because you're never going to insert or delete anything from an array. But vectors are different. Vectors, you might want to insert things into arrays or delete things from arrays. So how do you do that? Okay. Let's go back to Replit. Can I go back to Replit? Please, can I go back to Replit? There we go. Okay. Magic is kind of correct. Okay, let me just define a vector called a, because right, why did I do that? Okay. If I wanted to add one element, there are two commands. I can do pushback as it suggests. Basically, what this will do is append a value. So here, is nothing. After this, is 1. If I repeat this, is now 1, 2. So stuff like that. With this works. There's also, I think, dot insert. But if you want to understand what the hell a const iterator is, or whatever, I guess. Okay, this is an iterator. This is beyond the scope of our class. But basically, we want you to avoid using inserts. We want to avoid putting an element in the middle of the vector. So it turns out vector isn't that flexible. If you remember what we said about arrays and everything being stored in contiguous blocks of memory, that still holds true for a vector. So like if I have 1, 2, 3, 4, if I want to add 5 at the end, oh, okay, here, just 5. If I want to, if I want to add a 6 at the end, okay, sure, we can do that. If we want to delete the last element, that's fine. That's fine. We can do dot pop back, and hopefully I'm just gonna ask Copilot. No, it's not going to. Okay, that's fine. Now is 4, 1, and 2. If we want to delete one from the back, that's possible. But what we don't want to do is insert things in the middle. Turns out when you try to do this, it creates a completely different array, copies everything back in, but correctly this time. And so that's going to be a very expensive operation. So yeah, vectors treats them as if you can only add one element to the back, or delete an element from the back. This actually resembles a data structure called a stack, if you want to look to it, if you're curious. Stacks are quite fascinating, and I don't have time to get into it here, but yeah. Okay. Make your own vector. I guess we've kind of done this already, and it's not very interesting. You've already probably made vectors already. What else do I need to talk about vectors? Yeah. Okay, array versus vector. When do you want to use which? Okay, the pros of an array is that it's memory efficient, because as it turns out, a vector will need to like store the size of the vector, basically how many elements are in it. And so that's going to be slightly more expensive. Also like the accessing and stuff, because it like needs to resize itself, that's a bit less, that's also going to be a bit more expensive, so not the best. The cons of the array is that it has fixed size, and the vector can, you can actually insert and delete elements, although it's not very efficient. If you're wondering if there's a data structure that will allow us to say, okay, we want to store a list of numbers, we want to be able to access any elements very quickly, we want to insert elements in the middle quickly, we want to delete elements quickly. Unfortunately, there really isn't a data structure that does this well. that while also preserving its order, obviously. Um, yeah, it's really hard to do this. I don't even know if there's active research going on into designing a data structure that can do this efficiently. But yeah, it's very hard. That's why there's a bunch of data structures. If I want to be cute and make a statement that's completely unfounded, but what I think is true, it's that the whole study of data structures, basically how to store data, is to be able to try to reach this, to try to be able to find insert elements very quickly, to be able to delete elements very quickly. I guess you can also like try to like apply element. You can also like consider operations on this. But yeah, this is kind of like your dream data structure that you'll never be able to get. So yeah. When should you use an array or vector? I mean, this is like kind of technical, and I really don't have a good answer to it. I would just say if use an array when you're supposed to use an array and a vector when you're supposed to use a vector. If you have a fixed size, go for an array. Like a vector, you can do it, but like array, I feel like is just much more simpler, much better. If you want to a dynamic array, then vector is obviously the choice. If you don't know what size it is, vector is the choice. Okay, 2D arrays and vectors. Turns out you can also store like grids of elements. So like you're gonna do 1, 2, 3, 4, 5. That is not a 4. That is a 0. That is not a 0. 7, 8, 9. Boom. You want to do something like this, it's also possible. To add another dimension, you just add another layer of brackets behind it. And then like, yeah, like in this next thing is the same. This is the first row element of the first. This is the first element in the first row of the array. If you want to do like a vector, you can have a vector of int. That'll be a 2D vector. Oh, there's also this resize function that can like change the size of the vector, I guess. Yeah. Basically resize works like if you have an array if you have a vector of 1, 2, 3, if you resize it to something bigger, it'll add zeros at the end. If you resize it to something smaller, then it'll delete everything behind it. So yeah, that's how resize works. Yeah. Choose arrays and vectors. If any of you are going to take CSA, which is unfortunately not in C++, and I think that is really dumb, or even Python, it's in flipping Java, which is dumb. But anyways, if you take APCSA, this will be, I think, among the harder concepts. So yeah, just be careful. Traversing 2D arrays and like, yeah. Ooh, didn't I get to traversing arrays? Whatever. Ooh, I should have this as an exercise. Okay. It's already been shown on some of the slides before, but if I have like an array of 1, 2, 3, then how do I like print out every element, for example? For those of you who didn't get the question, how, oh shoot, is it pause? It's fine. Generally it's correct. Check your for loop syntax. And actually, you can treat the array variable as you can treat the array and the index as a variable by itself. So you actually don't need to like add an intermediate variable, an intermediate temporary variable to print out. You can just directly see out R of I, for example. I'm actually not sure if you're allowed to do that. Wait. Um, oh, right. Elaine, you can't do that. It's yeah, another case where C++ is a bit less efficient than Python. Does Python even allow this? I don't know. But yeah, you have to individually go to each array element and then print it out. All right, for the great reveal, um, okay, Elaine, that's cheating. You should not use a for loop. Okay, so the way you use a for loop is just for int I equals 0, I less than 3, I plus plus, out array I. Okay, this is how you print out every element of an array. Now, what if we did this with a vector? Where we don't know what the size is. Well, I guess we definitely do know what the size is. We can just use vec.size function to get the size. But how would you print out all the elements of a vector? Okay, like now that looks more like it. Ooh, James, you're off by one. That's so close. You almost have it. You did something a little extra. James is correct. All right, I'm just gonna show the printing the vector. So I guess I'll give everyone a bit more time. All right, how much more time do you all need? Okay, that's also correct. So I think I'm just gonna share the answer now. The answer is gonna look something like. Oh, wait, no. Elaine, the size isn't necessarily 3, so um anyways, I'm just gonna show everyone James's answer. It is this. Basically, yeah, we just replaced the 3 from the last time with the vector dot size. And this makes sense obviously because 3 was the size of the array. Okay. Now let's just integrate this with structs. Is the last thing we're going to do today. Basically, let's say we can have a struct here, and then in a struct, you can obviously have a vector inside it, and that everything works the same. You can also have a vector of a struct where you just put the struct inside here, and then yeah. This is a special notation of a for loop. I think it's called a for each loop. Basically, it will just say, okay, let's go through this student, and for every single student here, I'm going to copy this into this student. I'm going to copy the students at like, I'm going to make a copy of every student and then put it into here. And so like, for example, this is the first student. The student has some grades. And so it's gonna print out the grades, and the next student is gonna do the same. So yeah, basically this does basically the same thing as this. The advantage of using this is that this is cleaner, but the disadvantage is that you don't know the index. So yeah, use when appropriate, I suppose. Let me move this around. Yeah. So basically, yeah, that's about it. Is there anything else I need to go talk about? Doesn't look like it. Well, yeah, though then thanks everyone for coming today. Yeah, goodbye.
Bye.
Goodbye. Yeah, so I'm in the meeting right now, I guess.